Alright guys, today we're talking about writing linear situations in standard form. Okay, and I just want to start off by saying what standard form looks like. So maybe above here, standard form. Standard form would be a coefficient in front of the x plus, could be minus if the coefficient is negative, coefficient in front of the y equaling a constant. Okay, so far we have talked primarily in terms of y equals mx plus b, or f of x equals mx plus b. Standard form is a form that can be used for certain linear situations based on the information that you are given. So we're going to start at the beginning of lesson 3.2 in your textbook, and what I had you do in class was to read this part. The Marshall High School Athletic Association sells tickets for the weekly football game. Students pay $5 and adults pay $10 for a ticket. How much money would Athletic Association collect? So if 100 students came, so 100 students, and students are $5, so that's times 5. And there are 50 adults and they pay $10. Okay, so that would be 500 plus, 50 times 10, that's 500. So that would be 1,000. Okay, 125 students times 5 and 75 times 10. Well, 125 times 5 is 625. 75 times 10 is 750. So that would be $1,375, $1,375. Okay, so, and then there's a part C, and it's the same idea. And what we're leading toward is noticing, let's see, explain how you can determine the total amount of money collected if you know the number of student tickets and you know the number of adult tickets. Okay, well, that's pretty simple. You multiply the number of student tickets, by 5, and you multiply adult tickets by 10. Okay? Crap, I wrote that in the wrong spot. Let me move that. There we go. That was supposed to be question 2. My bad. Alright, 3. Write an expression. Write an expression to represent the total amount of money collected. Use S. Let me blow this up a little bit more. There we go. Use S to represent the number of student tickets sold, and A to represent adult tickets. So guys, don't overthink this. It's $5 for every student ticket. By the way, I hate S for a variable, but if the directions didn't say so, I wouldn't use it. Because they did, I am going to use it. And $10 for every adult ticket. Basically, guys, when you're reading these questions, it's going to sound like you have 2 rates of change and no y-intercept. That's what it sounds like. $5 per ticket sounds like a rate of change. $10 per ticket sounds like a rate of change. And we write them next to the variables. But they're 2 different variables. Okay? Alright, explain how your expression represents this problem situation. Well, that goes back to 2. We're multiplying 5 times the students and 10 times the adults. Guys, the next part in your book shows f of s comma a. I'm going to tell you that in 15 years I have never ever seen that notation for standard form to put an F of in front of it. I get it, I understand it, but it's not really anything we're going to use. Okay, so problem 6 is just subbing in more times. I don't think we need to do that. Okay, Carla and Robina sell game tickets. They have already sold 95 student tickets. Carla says they need to sell 252 adult tickets to reach the goal of 3,000, but Robina says they need to sell 253 adult tickets to reach the goal. Who is correct? Okay, so we've got 95 student tickets plus, hold on, so $5 times 95 student tickets plus $10 for every adult ticket, and we want to equal 3,000. There's a couple ways you could go from here. 5 times 95 would be 475. Let me check that. Now we could pretty much solve this like a basic 2-step from here. So subtract 475, subtract 475, and I get 10A equals 5, 2, okay, 2,525. Divide both sides by 10. Divide both sides by 10. Now mathematically it comes out 252.5. So mathematically it seems like neither of them are correct. But, guys, can you sell 0.5 of a ticket? No. If they sell 252, they're not going to quite make it. They have to round up to 253. The other way you could have solved this is to sub in. Let me make that bigger. Sub in 252 and 253 to see if it would work. So this is 475, and if I sub in, well, let me move that over so it fits, times 252, you can solve in and sub in and see if it works. 2520. Okay, add those together. 5, 9, 9. Oh, $2,995. 252 tickets does not quite make the goal. All right. Excuse me. So standard form and slope-intercept form are our two vocabs. Okay, slope-intercept form, I hope you remember, is y equals mx plus b, and standard form, I just wrote it down from the beginning of this. All right, so the first set says define the variables and write an expression to represent the situation. So you can see the example in number 1 and read that. But if I were doing number 2, and let's blow this up a little bit. Oh, I can't blow it up that much. Okay, here we go. Number 2 says a photo printing website sells 8x10 prints for $4.99 and 3x5 prints for $1.99. Write an expression to represent the total amount the website can earn selling 8x10s and 3x5s. So what we need to do first is set variables. So we have 8x10 prints, 8x10 prints, and 3x5 prints. Okay, so we need to make up letters. How about E for 8 and T for 3? Okay, doesn't matter. Make your letters at least make sense, okay? Then this is $4.99 each. Each sounds like a rate of change, and $1.99 each sounds like a rate of change. So $4.99 for the 8x10 prints and $1.99 for the 3x5 prints. Don't overthink this, guys. That's all there is to these problems so far. Okay? The next section, you're defining your variables and writing an equation. In other words, we're taking it a step further and making it equal to something. A bakery sells bagels for 85 cents each and muffins for $1.10 each. The bakery hopes to earn $400 per day from these sales. Write an equation that represents the total amount of money they would like to earn selling bagels and muffins. So first, define your variables, okay? They want to know how many bagels, how many muffins. So let's use B equals number of bagels and M equals number of muffins. So 0.85, 85 cents for every bagel, plus $1.10 for every muffin, and they hope that that equals $400. Okay, now, can I find out what B and M are? Nope, not yet. I don't have enough information to do that. They could sell one bagel and all the rest muffins and make $400. They could sell a bunch of bagels and no muffins and make $400. If I have two variables and one equation, I can't figure out which one is which. Okay? Alright, the next set of problems up through problem 18 are all having to do with this basketball booster club situation. They're selling hamburgers for $2.50 each and hot dogs, $2.50 each, and hot dogs for $1.50 each. They hope to earn $900 during the tournament. The equation is right here. Represents the total amount the booster club hopes to earn. Use this equation to determine each unknown value. So basically, guys, they're giving you a number to sub in, and you just have to sub it in for the right letter and then solve for the other one. So if the booster club sells 315 hamburgers during the tournament, how many hot dogs must they sell? Let's go actually on to 14. So the equation was $2.50 for every burger plus, I gotta look it back up again, I want to write it exactly the same. $1.50 each equals 900. Oh, plus $1.50 each equals 900. And they're saying, well, what if they sell 420 hot dogs? Okay, H stands for hot dogs. I'm going to sub 420 in for H so I can figure out the burgers. Plus $1.50 times 420 equals 900. Multiply that out. $630 equals 900. Okay, now it's a basic two-step. Subtract 630. One thing I dislike about the example that the homework gives you is that it does not show all the steps of solving an equation. It skips about every other step. Divide both sides by 250. And I ran out of room, so 270 divided by $2.50, 108. So they'd have to sell 108 burgers. Okay, have a great day. See you next time.